Okay, here's problem number 2 from assignment number 8. This is a different kind of problem. This is different than pretty much any other problem that we've seen, but it's similar to a big idea that we practiced throughout the entire first semester, and that is, hey, if I know a point, and I'm just going to mark this point, over 1 up 10, okay, and I know a slope. Now you say, I don't really know the slope, but I know the slope is always bigger than 2. So what I want you to imagine is that I'm going through that point, and that I could draw a slope of 2, but the real slope is something bigger than 2. So the real function, whatever's going on here, it's got to be above that dotted line where I assume that the slope is exactly 2. Right? Now, I can use the black dotted line and go over to 4, and that point there has to be smaller than the real function's value, because the real function's value had to grow greater as it moved away from the point 110. So let's say I have this tangent line, or something that assumes to be the tangent line, 10 plus 2x minus 1, and let's use that to say, well, what would happen at 4? Oops, 4 minus 3, 4 minus 1, so we get 10, 4 minus 1 is 3, 3 times 2 is 6, so I would say, based on this thing, that the functional value can be no smaller than 6, or 16. Okay, it can be 16, it's going to be 16 or higher. It'd be 16 if the slope is exactly 2 for the entire length of there, but since the slope could be bigger than 2, then it's 16 or higher. Does that reasoning make sense?
Yeah.
All right. All right, so that's problem number 2.